and welcome to this module series of a system design. Now, in this system design, we are trying to target this curriculum for someone who is trying to just begin their journey in the world of a parallel program. So, we are going to explore how to design the systems that efficiently leverage the parallel computing. Whether you are building a high performance applications, distributed systems, or optimizing machine learning pipelines, understanding the parallel architecture is critical. Okay, so let's dive in. Okay, so we'll start with what is the basics of the parallel programming. Okay, so fundamentally, parallel programming involves a breaking down of your task into the multiple subtasks that can concurrently execute. Okay, so what do I mean by concurrency? That you're going to manage your task in such a way that you can run multiple tasks at the same time. So, see, you have a task at your hand, and what you'll do is you will divide into multiple subtasks. So, task X1, you can define another subtask as X2, and this are nothing but a subtask which you are going to produce. So, this is called like breaking down your task into subtasks, and you can run them concurrently this both the tasks. Now, you can run this task concurrently across either multiple processors, multiple cores, or the machine itself. So you can say that you have multiple processors on your system. For example, this is a processor 1 and this is a processor 2 in itself. Another case is that you have running on the multiple cores. So if you just enlarge a processor, you can find out that you have multiple cores. Core 1, core 2, 3, core 4. So you can divide and distribute your task across this multiple core also. And what you can say is this is a one system one. And what you can try to do is similar to the system. You may have another system two and so on. So this is called the breaking down your task into the various machines. So this is a fundamental, like this is how you can run your parallel program. So with that, let's start. Like you need to start raising the question that why we need this. Why is a parallel programming required? So that's the right question. So what happened? So decades ago, there comes Gordon Moore. So he predicted something. What he did is that over the years, like every 1.5 years, you may see that the number of transistors that you are having on the same amount of size of the core that is going to increase. Okay, so if you have this as a unit of a course at this year, say year one, then by the time you are reaching to this year, it is going to be doubled. So at here, so it has already got doubled when you are reaching here. Now, what happens that you are reaching to the next year? So when you're reaching to your next year, your number of transistors again double. So double to this. Now you can see this pattern, that this pattern is rising exponentially. So when this pattern is rising exponentially over the early span of years and even till now, but recently what we are trying to see as this graph is being branching. Okay, so we don't see this much exponential curve rising because there is a limitation that we can accommodate the number of transistors without any error on the same die. What is happening that there's a quantum effect which comes into the play when you're trying to go and smaller into the core size and transistor size. So there is a lot of errors coming because of the heating effect, electromagnetic effects. So what can we do? So what we need to do is the demands are not stopping. The demand for the need for the speed is keep increasing. So we have an application to run like real-time analytics. We have application to run the simulations, and we have the AI applications also in this modern computational power. It requires computational power. It requires a more and more performance to draw from the system. So what is it? Is parallelism is just running into the more and more threads? It's not. It requires a really careful system design. Then only we can achieve a great program and we can harness the maximum out of the system that we design. Okay, so with that, we'll see you on the next module with the architectures which can be designed for parallel system. Thank you.